Let's talk about similar triangles. Two triangles are similar if three angles in one triangle are equal to the three angles in another triangle. This is angle A, angle B, and angle C. Angle D in the second triangle, angle E, and angle F. So what the similar triangle statement says that if the three angles in triangle 1 are equal to the three angles in triangle 2, then these two triangles are similar. So let's write that out. So what that's saying is an angle BAC is equal to angle EDF and angle ACB is equal to angle DFE and angle ABC is equal to angle DEF. And if that's true, then these two triangles are similar. If that's true, these two triangles are similar. There's another statement about similar triangles. Another statement says that in two similar triangles, a side of one triangle is said to correspond to the side of the other triangle if these sides are opposite equal angles. So let's look at our triangles, triangle 1 and triangle 2. Side A, denoted by the lowercase letters, is opposite angle A. And side D is opposite angle D. And side A and D, we just said, are equal angles. Therefore, if side A and D are opposite equal angles, they are said to correspond. And when two sides correspond, we can write them as a ratio. And when we write two ratios equal to each other, we get a proportion. So what that says is, since these angles are equal to each other in triangles 1 and triangles 2, that means the sides correspond. Therefore, side A corresponds to side D, and side B corresponds to side E, and side C corresponds to side F. Right here, just like that. Because these sides correspond, we can write them as proportions. What you would know is, we can write them as ratios. And when we write two ratios to equal to each other, we get proportions. So therefore, that means I can write A is to D as B is to E. Or I can write A is to D as C is to F. And what this does is, this allows us to solve similar triangles in problems, in math problems. So let's see how this will work. Let's look how this works in assisting us in solving math problems. Let's take a look at an example. Okay, here we have a flagpole that stands some distance x above the ground, and we have a person that's either located in front of the flagpole or to the side of the flagpole, that stands a distance of 6 feet from the ground, from the top of his head to the bottom of his feet. And we have the sun shining down, and the sun and the flagpole cast a shadow of 20 feet. And the person cast a shadow of 2.5 feet. The person standing up on the ground makes a right angle with the ground, and the flagpole, as you know, is vertically up, and it makes a right angle with the pavement. So these triangles are similar because each angle in triangle 1 is equal to each angle in triangle 2. And because that is so, we can write these angles, sides, as corresponding sides. So that means I can say that x is to 6 as 20 is to 2.5. And now, using similar triangles, that allows me to solve for the height of the flagpole. Well, because this is a decimal in the denominator of this ratio here, I can remove this decimal point by moving the decimal point over in the denominator. If I do that, then that makes that 25. But if I do that, I must move the denominator over 1 in the numerator and make that a 200. So that allows you to move away from fractions when decimals when solving the problem. So now our problem says that x is to 6 as 200 is to 25. Okay. Then if I multiply both sides by 6, the 6's cancel, and x is equal to 200 times 6 divided by 25. And so, let me divide my paper in half. And so now, that's x is equal to 1200 divided by 25, I'm sorry. X is equal to 1200 divided by 25. And that's equal to 48 feet. So the height of the flagpole is equal to 48 feet. And using similar triangles allowed us to solve for the height of this triangle, for the height of the flagpole. Now, I didn't have to use the right triangle number 2. I could have started with triangle number 1. And let me do that. Last time I said x is to 6 as 20 is to 2.5. I could have started with the smaller triangle. I could have said 6 is to x as 2.5 is to 20. Now, as you all know, in order to solve this equation, I have to get x by itself to solve for x. So I multiply both sides of my equation by x, so that x's cancel here. So that means 6 is equal to 2.5 times x divided by 20. Okay. Then I got to multiply both sides to get the x by itself. I have to multiply both sides by 20 over 2.5. So I have 20 over 2.5 times 6 is equal to 2.5 times x divided by 20 times 20 divided by 2.5. Well, 20 cancels with 20 here, 2.5 cancels with 2.5 there, so that leaves me with x is equal to 20 times 6 divided by 2.5. Now, to remove the decimal in the denominator, I have to move the decimal point over in one place in the denominator, and if I do that, I have to do the same thing in the numerator. So x is equal to, and so last time I made the 20, I moved the decimal point over on the 20, but I don't have to move it over on the 20, I can move it over on the 6. So I have 20 times 60, because I moved the decimal point over 1, divided by 25, because I moved the decimal point over from here to here, 1. And I moved the decimal point over here to here, 1, so I put a 0 there. So that's 20 times 60. Well, 20 times 60 is 1200 divided by 25, which we had before. So therefore, x is equal to 48 feet. Same answer. So either way you do it, you get the same answer. And that's what's so great about mathematics. Regardless of which way you perform it, if you do the mathematics correctly, you'll get the same answer. Let's try another problem. This time we're going to look at a problem maybe that we'll use in everyday life. Let's look at a pond. I have a pond here, and we need to calculate the distance across this pond. And the distance across this pond, we want to calculate the distance AB. And this pond is defined by the blue outline here. And we want to determine the distance across this pond. Well, we could get inside of a canoe and put a stake on at A and take a canoe all the way across with some rope, some line, and measure the line. But then we wouldn't know if we're straight across the pond, and so we still wouldn't know how wide the pond is. So let's try mathematics. So let's put stakes here at A and at B, and we put the stakes at C, D, and E, and we take a level and we level. Make sure that DE is parallel to AB. We're like surveyors now. Okay. So once we get these stakes in, now we have two triangles. We have triangle ACB, and we have triangle DCE. And these triangles are similar. So if these triangles are similar, then we can write their corresponding sides as ratios. So, okay, I've written up here at the top, we're looking for AB. We don't know what that is. And we measure DE, and we measure DE as 60 feet. DE, we measured that with a scale, and we measured that at 60 feet. CB, on the larger triangle, we measure at 70 feet, and EC, on the smaller triangle, we measure that as 50 feet. So therefore, we know that, let me get my cursor back here. We know that AB is to DE, AB that we're looking for is the DE corresponding side. As CB, the large triangle, side on the large triangle, CB, is to EC. Because they're corresponding sides. And because they're corresponding sides, then we can solve for AB. So AB is equal to DE, which is 60 feet, is equal to CB, which is 70 feet, divided by EC, which is 50 feet. Okay? And now to solve for AB, we have to get it on the side by itself. So we multiply both sides by 60. 60's cancel. So AB is equal to 70 times 60 divided by 50. 70 times 60 is 4,200 divided by 50. Well, one of the zeros can cancel. So then we have AB is equal to 420 divided by 5, which is equal to 84 feet. AB is equal to 84 feet. So using similar triangles, we've determined the width of the pond without measuring, just using mathematics. And that's what similar triangles does. Similar triangles aid in solving mathematics problems. Now, let's see what we'll do if what happens if we take this problem and we change it a little bit. And that's what happens in mathematics. You can have the same problem, but they look differently. So let's see what happens if we change it a little bit. Okay, so we have same pond. It's just that I've rotated it a bit. And so it's at some angle. Now you'll notice that the first problem we solved was a right angle, right triangle. And the second problem we solved was not a right triangle, and this problem is surely not a right triangle. So similar triangles can be used in any angle, any triangle. So we're looking for AB. So we still have our stakes here at A and B. It's just that we drew a line out from B to C, same thing we did before, but this time this is a different, it seems like a different triangle. So let's see how we would do this. So we would take DE and level it and make sure it's parallel to AB. AB is not a line there. There's nothing there. There's just the width of the pond. So what we have is we've measured CB again. And now, since this is a different pond, we got CB equals 1,000, DE equals 875, and CE equals 675. So let's see how we would write that. We would write this as corresponding sides. Well, AB is the DE. We would write AB is the DE because AB and DE are corresponding sides because they're both opposite equal angles. They're both opposite angle C. Okay, so then we have is equal to, that's the large triangle is the large side, AB, is the DE. We started with the large triangle first. So that means we got to start with the large triangle next. So that's CB is to CE. Okay. So that's equal to AB is to DE, 875, is equal to CB, which is 1,000, is to CE, which is 675. And we multiply both sides by 875, so that way we have 875 times AB over 875 is equal to 1,000 divided by 675 times 875. 875's cancel. So we have AB is equal to 1,000 times 875 divided by 675. And if you break out your trusty calculators, you will get that equal to, you will get AB equals to 1,296.3 feet. And so we've calculated the distance across that pond without measuring it. We just use mathematics. And that's what mathematics does for you. So if anyone ever asks you why you waste your time studying mathematics, tell them why. It helps you solve problems. And that's the difference between mathematics and arithmetic. You use arithmetic in mathematics. You need to know arithmetic to do mathematics. But mathematics allows you to make decisions with arithmetic. So once you learn arithmetic in the 8th grade, then you move up to, from 1st grade through 8th grade, you learn arithmetic. And then after that, you move from 8th grade to 12th grade. You learn mathematics. And mathematics allows you to make decisions with the arithmetic that you've learned. Okay. The next video we'll move to is scale drawings. And I want to talk to you about scale drawings because if you ever use a map, you need to know how to read a scale, because maps aren't drawn to size, they're scaled down. And if you ever bought a home, or if you've ever buy a home, the drawings you get will be drawn to scale. So you'll need to know how to interpret sizes from the real object to the object on your drawing. And so if you load up basic trigonometry scale drawings, we'll talk about that.